proofs involving parallel lines. Okay, first thing we need to say about this is this little disclaimer they have at the top. You are not allowed to use transitive property for parallel lines. What that means is typically in these ones, they've given you enough information that there are usually 3 sets of parallel lines. And they might have given you, say, I need a little thicker here, that maybe UV is parallel to ST. So that means that this one and this one are parallel. And then QR is parallel to ST, so this one's parallel to this one. It's really tempting to say, well, that must mean that UV is parallel to QR by transitive, because that feels like a transitive rule. You know, if A is equal to B and B is equal to C, then A is equal to C by transitive. But parallel rules don't apply, okay? You cannot use transitive for parallel for some reason. So, cannot do, all right? Not allowed. All right. So, now that we've got that rule, the only way that you can prove parallel, in fact, if you want to write this down in your notes, only way to prove parallel is with angle relationships. You know, corresponding, alternate interior, alternate exterior, consecutive interior. There we go, like those. Or the perpendiculars, which we don't do in ALEKS. These ones are not in ALEKS. Okay. All right. So let's look at this one that we've got in front of us. They have given us that UV is parallel to ST. So we looked at that. This one and this one are parallel. Good to know. So let's mark that on there with our black pen. This one parallel to this one. And QR is parallel to ST. So this one is parallel to this one. Good. They've also given us that 8 is congruent to 1. And they want us to prove that 4 is congruent to 3. That's what they want us to prove. Okay. What I want you to know, I'm going to color those in here. These guys, they want us to prove those are congruent. What I want you to encourage you is, if you're given angles down here, try and connect them, where's my pen, to the ones up here. Make a connection, if at all possible, somehow, so that you can get them linked, okay? Connect the prove angles to the given angles. That's going to be our goal, okay? All right, so we're going to set it up down here. I'm going to bring all of my givens down into here, and I'm going to write down my givens. Okay. And then I'm going to bring in what I can. Let's see. I'm going to do this actually in the proof, and I'm going to show you how that works. There we go. Oh, hopefully it doesn't refresh. Yep, it did. Okay, well, then I guess we're going to write them over here. No, it didn't. There it was. Did we see it? There it is. Nope. Ha ha ha. Oh, are you guys getting dizzy yet? I am. I guess I am writing it out. Here it is. Okay. So the whole proof, I guess we're writing it out by hand. UV parallel to ST. Angle 8 congruent to angle 1. And QR parallel to ST. I would bring all of that in. Given, all in there. And then I would try and bring in that angle 4. And I would set him equal to one of those angles up here if I at all possible could. So Angle 4, how is he going to be equal? Angle 4, well, he's on a line parallel to U and V. I'm going to extend T out a little bit here. There we go. Angle 4 is down on this side. Let's see, he is with 8. He's a corresponding angle. Okay, so that could work for me. With 1, he's nothing. He's not an angle relationship that I can exploit. So 4 and 8, that's what we're going to go with. Angle 4 and angle 8 are congruent because of corresponding angles. And specifically, we're going to have to use the words that say, if lines are parallel, then corresponding angles are congruent. That's what we need to have. That's going to be our next line. There we go. Okay. Then we want to bring in angle 3. Let's see. Or angle, yeah. You know what? I'm going to go ahead and link these. Let's see. Can you see this? I've got 4 going to 8. To 8. And then 8's up here. And then there's 1. That's a transitive link. I don't know if you can see that. 4 equals 8. And 8 equals 1. We talked about transitive, didn't we? That means that angle 4 is congruent to angle 1. I'm going to write that down. I've now proven that angle 4 is equal to angle 1. So I'm going to write that down by the transitive property. Okay? I can only link 3 things at a time. So I have to do that every, by 3 at a time. Okay, so there we go. Got that done. Now what am I going to do? Okay, I'm going to link in 3. So I'm going to say angle 1, no, angle 3 is congruent to, look up here, angle 3 is going to be congruent to angle 1 up here because they are alternate interiors. If you got to kind of picture it. I'm going to even, oh, nope. If you can't, you can kind of look at that. 2 lines, they're alternate interiors. Yep, there we go. And you might notice that I'm putting angle 3 last. It's just that I can see that there's going to be another transitive link here. Let me see, alternate interior angles. Let me write this down. Okay. And I'm not writing the whole thing here, but I need to, so, oh, don't forget those dots. Okay, bring those down. So, if lines are parallel, then alternate angles are congruent. Okay, there we go. Now, let me go get my colors again. If I've got angle 4, and then 1 here, and then over to 3. Look at that is a transitive link. See? These guys are in the middle. So I can link angle 4 to angle 3 by transitive. There we go. And I have now proven that angle 4 is congruent to angle 3. So that would be my whole proof that I would type in. It takes a little bit more thinking. You have to work your way through it. But when I start, I make my plan before I get going, and I try and connect my proof to the angles that they've already got going. Okay.